Formed in 1970, Airbus Industrie has a range of 7 aircraft used by 120 airline customers around the world. Every wing set of the 1,300 Airbuses in service was developed and assembled by British Aerospace, a key partner in the Airbus consortium. To meet the demands of today's airline industry, British Aerospace and the Airbus consortium are faced with 3 key objectives: to produce aircraft that are easier to own, maintain, and operate. Because price is such a factor in this industry, cost reductions must exceed price reductions. They must cut lead times from 4 to 2.5 years. To meet these objectives, they realized they had to abandon the serial methods of product development, replacing them with a concurrent engineering approach. They had to adopt an integrated product development approach and achieve for the first time a consistency of product development process and a commonality of information used within the process. To do this, they had to adopt a common product development software program. In July of 1995, British Aerospace, along with their Airbus partners Aerospatiale and Daimler-Benz Aerospace, acquired Computer Vision's electronic product definition software and services capability. This EPD capability allows them and their suppliers to fully define, analyze, and assemble a complete aircraft within computer software before committing it to manufacturing, confident that it will be right first time. During the extensive research leading up to the agreement with Computer Vision, they looked at the technology and the ability to meet the changing business requirements now and into the future. The product development structure established will see them into the 21st century. To test the viability of Computer Vision's EPD capability to be implemented and meet their key business objectives, British Aerospace set up a pilot project to fully design and assemble a wing. They put a team together to create the electronic product definition of the wing, defining and capturing the new development process as they did so. They used Computer Vision's Optigra product data management system to manage, track, distribute, process, and make secure all of the product data, no matter from where it was sourced. This information is able to be recorded and managed throughout its life cycle, from concept through to product retirement. CADS5 was used to define all geometry, solids, surfaces, and wireframes in explicit and parametric forms. They also used it to create piping and harnessing. Initially, they defined the product structure with Optigra Navigator, establishing boxes and a tree structure which would later be populated with relevant information in a seamless process from concept through manufacturing. The individual team members' responsibility was to organize this configuration to support design for manufacture, which would be achieved because all team members contributed and shared the same information from day one. Soon, other team members started to add raw geometry in terms of interfaces, where ribs, engines, and pylons were to be placed, and where the wing joins the body of the aircraft. The team was 1/10 of the way through the new development process. With the traditional process, this would have taken 2 years. Also, this information could now be shared with customers and suppliers, providing them with early involvement in the process using the system for information distribution and feedback. They would be able to begin working on support functions, such as cabin layout, servicing, and manufacturing requirements, for example. This would help realize early cost reductions and get the process and design right first time. At this point, the team refined the product. What started out as raw CADS5 models became precise definitions. Still using the same previously created information, they were able to optimize the design and realize large time and cost savings because no recreation was necessary. The project was now 1/5 of the way into the 2.5-year process. This would have taken 3 years in the conventional mode, and earlier decisions have already been made, such as which suppliers are to be involved and what information they bring into the development process at this early stage. As the team began detailed design, they were about 2/3 of the way through the process. Ironically, this is where they would have begun under traditional means, but detailing in EPD is used more to record data sets relevant for subsequent processes, such as surface finishes, paint specifications, and tolerances, In essence, they are seeking to eliminate drawings altogether, relying on electronic distribution of information through effective data management. As the manufacturing of tooling began, the team shared the exact models developed in the earlier stages of the process with suppliers. They were confident that all design for manufacturing considerations had been made using the electronic product definition of the wing. When the full definition of the product was finally released, a complete data set for the wing, or if undertaken, the aircraft, was now resident on the system. This included all information developed over the length of the project: CAD files, analysis files, specifications, animations, spreadsheets, even videos. With a unique configuration originally defined with the Optigra Navigator, they are able to deliver an aircraft or wing as defined, as built, as modified. They are able to simplify traceability, to find out who supplied what on which aircraft, find out what was early, what was late, what performs and what doesn't, what concessions were made, when, where, why, and by whom. In the final assembly of the wing and the total aircraft, the electronic product definition model will provide online information to the fitters, eliminating huge amounts of paper documentation. The ability of Optigra Navigator to supply video and animated sequences will prove invaluable in following the assembly sequences against the unique specifications of each product. They can be confident they can supply an aircraft to their customer with the complete product development information, easy to access, making it much easier to operate and maintain. What this unique pilot project demonstrated to British Aerospace and to their Airbus partners was the electronic product definition capability provided them and their suppliers with a visibility and an accessibility to the development process never seen or realized before. They estimate that on a complete full-scale wing design, they could now realize a 50% reduction in lead time. They now have the ability to change every technological tool, every process, and every project team to realize these gains. British Aerospace is now moving to the full deployment of the EPD capability, looking for the same objectives: reductions in cycle times, development, and recurring costs. They are convinced that the EPD capability will greatly help them in meeting the distinct needs of their customers, deliver a concrete competitive advantage, and increase their market share.